Here are your video notes for lesson 5.3. We're starting a new chapter. It's chapter 5. You should probably start a new sheet of notes. Lesson 5.3 is about solving multi-step inequalities. And I've got some stuff written out already. If the video is ever going too fast for you, I'll pause it to keep up. First thing we'll do is define what is an inequality. And an inequality really is an equation, or at least it can be treated the same as an equation, but it's an equation where the equal sign is replaced with an inequality symbol. And when we say inequality symbols, we mean symbols that mean something different than equals. Examples of the three inequality symbols you probably do know. That's less than, that's greater than, that's less than or equal to, and this is greater than or equal to. I would like you to write underneath this one that says less than or equal to. A phrase for that would be at most. Most sounds like the word more and might indicate to you to think of greater than, but at most means you're going to have to be less than or equal to something. A phrase for this symbol of less than, or excuse me, greater than or equal to, the phrase for that would be at least. Alright, we'll go through some examples here. Three quickly for you. Basic ones. You're probably aware that we are skipping 5.1 and 5.2 if we're starting at 5.3 in chapter lesson 5.1 and 5.2. We are skipping. Example 1 that I'll have you do is 5x. X plus 5 is greater than 6. If you'll copy these down with me, example 2 will be 5x is less than or equal to negative 30, and example 3 will be negative 3n is less than or equal to negative 15. Okay, we solve these the same way we would solve equations, where we want to try to get the letter by itself. So to do that, we got to get rid of adding 5. We would show minus 5 minus 5, and the result of that would be that we have x is greater than 6 minus 5 is negative 1. If we go over here to example 2, and this is the stuff you would find in lessons 5.1 and 5.2, so we would be looking at getting x by itself. To get rid of multiplying, we would divide. We would divide over here. So our answer to this one would be that x has to be greater than or equal to negative 6. You will have to graph these. Don't get nervous on me about graphing. They are fairly simple to graph. What you're looking at is we have one variable here, and since we only have one variable to graph these, we only need one number line. So I'm just going to draw a number line down here. Most important number to put on the number line is going to be this negative 1. So if I put negative 1 on my number line, I would just like you to put a number smaller than negative 1, a number bigger than negative 1 next to it, and circle it that this is the most important spot on the number line. From there, we will shade what our answer is. And if we're looking at the mouth says x is what? The bigger values or smaller values? The mouth opens towards x, so x is bigger than the negative 1. We simply need to show shading over here on this side, and that is graphing it. If we go to the next one to graph, our most important number to put on our number line is negative 6. We'll throw on negative 7. We'll throw on negative 5. We will circle this to show that's our important spot on the number line. And then we should be looking at it and saying, we're going to shade what are the possible answers. This says x is greater than negative 6, so once again we would be shading this way from the negative 6, but the line underneath it right here says it could be equal to negative 6, which means we need to shade the circle, and the circle will get colored in too. So our graph is going to look like that with a closed circle instead of the open circle on the first one. So if we go through now and solve the last one, the reason why this is here, there's a trick to doing this one. Here we are going to have to divide both sides by negative 3. And if I divide both sides by negative 3, those will cross out and give me a positive 1. To have positive 1 times n is now less than. The negative divided by a negative turns into a positive, and we would get 5. And if we actually, the board is not writing the way it should over here. Okay, I fixed the board so it's writing right. It will be that. There's a mistake in what I've done, and I'm going to erase the mistake. It's this. If you've learned this in the past at all, you'll probably remember it after I go over it. But if the number that you are dividing or multiplying both sides by ever is negative, it's this negative sign down there that's causing this. If that's a negative number, then the inequality symbol here has to flip, and it will become n is greater than 5. So now we are going to graph this. We'll show 5 here, 6 is out here, 4 is here. We will circle the 5, and we're still shading to the right here. So, alright, from here with that explained, what's actually in lesson 5.3 are multi-step ones. There's 3 examples of multi-step ones. If you'd like to go through, solve them ahead, I would like you to try doing that. Pause the video, and then you can unpause it to see them get done, or if you get stuck. And you probably also could scroll ahead if you went through, solved them, and had no trouble. Alright, unpausing the video now. I'm going to go through, show you the work solving these. To solve this one, we should add 5 to both sides. If we add 5 to both sides, we're going to get 2x is less than or equal to 28. We're going to divide by 2. Divide by 2, we're going to get that x is less than or equal to 14. Graphing that, I draw my line. Put the 14, there's 13, there's 15. Circle this, decide to shade so that x is smaller. This one's going to the left, and go back and color the circle in because it could be equal to. Solving this one, I need to distribute, and I will get negative 1/4 p. The negative times a negative will give me a positive. 1/4 times 12 is 3, is greater than negative 2. If I add the 3 on, I get that negative 1/4 p will be greater than 1. To get rid of multiplying by the fraction here, I'm going to multiply by its reciprocal, which will be negative 4 over 1, which is really to multiply by negative 4. These cross out. I now have p by itself is greater than, and I just made a mistake. We multiplied both numbers, or both sides, times a negative value, which is going to cause the inequality symbol to flip, and we will get negative 4. So, drawing my number line, my main concern is the negative 4. Here is negative 3. Here is negative 5. And we should circle the negative 4, shade so that p is smaller, which means we are shading off in that direction again. Last one down here, key thing about this, you have a variable on both sides. How do we handle that? Get them together on the same side by moving this term over to join this term. So I'm going to subtract 3x. There I get 0x, and whatever I do there I have to do over there. This now becomes 2x minus 12 is less than or equal to negative 4. If I add on the 12, I add on the 12. 2x is less than or equal to 8. Divide by 2, divide by 2, and x will be greater than or equal to 2. My number line or graph for this one would be where I need to put the 2 on. There's 1, there's 3. Circle the 2, shade so x is smaller. That's off to the left again. And I need to color the circle in because it could be equal to. I've shaded my answer. 2 more examples for you to try doing. You can work ahead on these, see what you get, and there will be something new that's getting taught by doing these 2 examples. And I'll come back and finish them. Doing them for you now, if you've unpaused the video, the 5 times m and the 5 times this, I get 5m plus 25 to be less than 5m plus 17. If I subtract 5m from here to get it together with these 5m's, positive 5m and negative 5m, that really zeroes out. So the m's have disappeared from both sides. I get that 25 is less than 17. We saw this before when we had equations with variables on both sides. When the variables disappear, we look at this and decide whether this statement right here, 25, is less than 17, decide whether it's true or false. That's actually false. If it's false, our answer for this is there are no solutions. There is no number that we could replace the m with to ever make that true. So we'll circle that to let you know that's the answer. If we come over here, we need to distribute the negative 4 here. We'll get 1 minus 8n is less than or equal to negative 8. This should be an n there. N, and negative 4 times negative 1 is positive 2. If I add these 8n on here to get a 0, then I have to add the 8n with what's over there. They zero out, and I now get 1 is less than or equal to 2. Once again, our variables have disappeared. We would look at this and decide, is this a true or false inequality that we have right here? It is a true inequality, which means our solution is all real numbers. And that means any number that we put in for the n up here will make this true on both sides. Sorry about putting the letter S there, that should have been an n. Symbol for all real numbers is this, and that concludes your video notes for lesson 5.3.